So guys, can you hear me now? Sorry, I was just looking for my pen.
Yeah, it's able
Okay,
to
you
hear
can
you.
see my screen, right? Okay, so in the last session, we talked about Kubernetes architecture, and also I'll share some documents by the end of the day on the Kubernetes architecture. Okay, so we understood about various types of nodes and various components running. But today we'll understand how to set up a Kubernetes cluster using Kubeadm. Okay, so Kubeadm is one of the tools available for setting up the cluster locally along with other tools like Minikube and all. Okay. So using Kubeadm, you can create minimum viable Kubernetes cluster that conforms to best practices of Kubernetes. And in fact, if you run any confirmation tests on the cluster, it will pass. Okay. So for creating Kubernetes cluster using Kubeadm, so we do have a lot of prerequisites. Okay. So these prerequisites are directly taken from the Kubernetes documentation. So we will be referring the Kubernetes documentation when we create the cluster using Kubeadm. Okay. So first of all, you should have Linux host machines. At least 2 GB of RAM or more is required. Okay, for running the master components, and there should be full networking connectivity between the master and the worker nodes in the cluster. And we should make sure that the host names and MAC addresses are unique for each node. Okay, it's not like you can make both a single node both as master and worker node. They should have unique host names. Okay, and each component in the master and worker node runs on specific port. Okay, so we should make sure that those ports are also open on the nodes so that those components can talk to each other. Okay, and swap should be disabled, and there should be at least one container runtime like containerd on all the hosts. Okay, on both master and the you know on the worker nodes. Okay, so as a container runtime, we are going to use containerd. Okay, so I'm going to explain why we are using containerd and not Docker. Okay, and this is the overall architecture of your Kubernetes. As you see, we have a lot of components running on various port numbers. Okay, like scheduler runs on this port number, controller, HCD runs on 2379, and your API server runs on 6443, and Kubelets runs on 10250. So along with that, if you're using any container runtime, that also requires some ports to be opened. Okay. So for this, what we will do is we will refer the official documentation of Kubernetes. Okay. And also I have a GitHub repository. So where I have clearly mentioned all the steps required. Okay. So if you go to my GitHub and then search for YouTube series. Okay. And if you go to Kubernetes in the cluster setup, you have both 1.28 version setup and 1.29 version setup. Okay. So this is the latest one, and I've updated all the relevant instructions. Okay, to install version 1.29 of the cluster. Okay, clear, guys. And of course, you can search for Kubeadm Kubernetes, and then you'll have various links here, like creating a cluster with Kubeadm, installing Kubeadm. Okay, so first we'll see how to install Kubeadm. Okay, so for installing Kubeadm, these are all the prerequisites. As I already said, you should have a Linux host with at least 2 GB RAM and 2 vCPUs, and full networking connectivity, unique host names. Swap should be disabled. Okay, and as a container runtime, so basically you need to select a container runtime uh, that works with container runtime interface. Okay, so Docker is not supported as of now. Okay, so Docker is only supported if you're using CRI Dockerd. So this is again one more add-on. Okay, if you're planning to use Docker, you should also install CRI Dockerd. So, but what I did is I directly installed Containerd. Okay, so did we discuss about why Containerd is being used instead of Docker in the previous session?
No, Vikram.
Okay, so let me discuss why Kubernetes has to stop supporting Docker. Okay, so we have three terms here like container runtime environment, container runtime interface, and Docker shim. Okay, so what are all these? Okay, so if you look at this Docker architecture, so Docker internally uses containerd, which is a runtime, which is a high level container runtime. Okay. And on top of containerd, Docker has implemented Docker CLI, Docker REST APIs, okay, Docker daemon. Okay, so all these we called as Docker engine. Okay, and internally it uses containerd, and containerd internally uses RUNC, so which is the low level container runtime responsible for creating all your containers using C groups, namespaces, and all those concepts. Okay. Now what happened is, in order for kubelet, okay, so kubelet is a component. Okay, so if I go back to the Kubernetes documentation, okay, so kubelet is the component which is running on all the worker nodes. So this kubelet is responsible for talking to the container runtime. It can be anything, okay, for creating the containers. Okay, now what happened is, for kubelet, okay, to talk to the container engines like Docker. So Kubernetes implemented so-called container runtime interface. Okay, so this is just like an wrapper. Okay, so if you have a kubelet here, okay, and if you have a container runtime, just like Docker and all. So what it did is, it implemented a container runtime interface. Okay, so why this interface is required is, in order to separate kubelet from all the container runtime implementations. Okay, so for example, in case if any new container runtime comes, kubelet need not update its code. Okay, so simply it uses CRI. Okay, and CRI takes care about talking to the backend container runtimes. Okay, so in order to provide that isolation, CRI is implemented. Okay, but in order for CRI to work, okay, all the container runtimes should implement Open Container Initiative. Okay, which means OCI. Okay, so what is OCI is? OCI will give you all the required, principles or standardizations, how your container runtime should be implemented, what all API calls you should be implementing. Okay, now CRA can use those APIs of container runtimes, in order to talk to them. Okay, so in this case, so even if you replace the container runtime, okay, kubelet need not know about it, because kubelet will simply use the interface to talk to the container runtime. Okay, but this is only true only if the container runtimes are created using OCI principles. But Docker is not like that. Okay. So Docker uses its own REST APIs. Okay. So Docker uses its own REST APIs. So which is not supported by your kubelet. I mean, your CRA will not understand. Okay. So which means if I have a kubelet, I cannot use CRI to directly talk to the Docker, because Docker is not implementing CRA specific APIs. It has its own REST APIs. So there is a protocol mismatch here. Okay. So where CRA uses gRPC, Docker uses REST APIs. Okay. So in order to bridge this gap, kubelet used to implement one more interface called Docker shim, okay, which just acts like an interface between your Docker and your CRA. Okay, so this is an extra component that your kubelet is managing. I mean, your Kubernetes is managing. Okay, but if you look at the architecture of Docker, so it already uses containerd, which implements CRA, which means it can understand CRA. Okay, so why do we use, what is the requirement of using Docker if containerd is already using CRA? Okay, so that's the reason what Kubernetes did is it completely eliminated the support for Docker shim. Okay, and then it is directly talking to the container runtimes like containerd without needing to use another interface called Docker shim. Okay, so that's the reason why they directly stopped supporting this Docker shim. Okay, they did not stop supporting Docker. It is they stopped supporting Docker shim. This is an extra. You can say this is an extra add-on. Okay, but I think some organizations, they what they did is they took Docker shim, and then they are starting to maintain it themselves. I think Mirantis or someone started maintaining this Docker shim. Okay, so kubelet stopped supporting this Docker shim. Yeah, you can see Mirantis and Docker have committed to maintaining Docker shim even after it is removed from Kubernetes. Okay, so you can still get if you want to use this, you can still use because it is being supported by Mirantis. Okay, got it, guys?
So Vikram, so still we can use Docker in Kubernetes environment. Is that
Yes,
right, Vikram?
yeah, you can use, but the thing is, you should use, as mentioned in the documentation, you should, after installing Docker, right, you should install CRA Docker D, this one.
Okay.
Okay. So only if you see here, this is from Mirantis. This is just like you can say it is a Docker shim. Okay. So they are maintaining it separately. If you are installing Docker, make sure that you're installing CRA Docker D. So your kubelet will now talk to this. Okay. But the question is how your kubelet will actually detect the underlying, your container runtime. Okay. So we all know that every container runtime listens on some unique socket, right? So for Docker, it is var run docker.sock. Correct.
Yeah.
Similarly, for all the container runtimes, there is an unique socket. Okay. So when you install kubelet, okay, so kubelet will automatically detect all these unique sockets, whichever is available. Okay. So then using this socket, it will automatically talk to the container runtime. Okay. So if I'm installing container D, I don't have to configure kubelet to talk to container D using this socket. It will automatically detect it. Okay. You can see here somewhere by default, Kubernetes uses CRI to interface with the container runtime. Kubeadm automatically tries to detect and install container runtime by scanning through list of known endpoints, which means it will scan all these endpoints to see if they are available. Then automatically, Kubeadm will configure kubelet to talk to these sockets. Okay, if you have multiple container runtimes, again, Kubeadm will throw an error. Okay, then you need to uninstall and then keep only one container runtime. Okay, so earlier the installation used to be very, pretty simple. We used to install Docker on all the machines, but now, the installation is pretty complex. Okay, so first what we have to do is we have to disable swap on all the machines. Okay, and then install container D, install low-level runtime RUNC, container networking interface. Okay, and then you should also use CRA-CTL. Okay, you need to install this. Okay, and then do some system level configurations. Okay, finally, okay, so we will install Kubeadm. Okay, and kubelet, kubectl. Okay, so Kubeadm will not install kubelet and kubectl. Okay, so it will install components like API server, scheduler, controller, HCD, okay, kube proxy and all. Kubelet we need to install separately. Okay, and then kubectl also we need to install separately. Okay, so these are all the uh, required tools before running or before bootstrapping a Kubernetes cluster. So all these are already listed in the official documentation only, but you will not find any of these suitable links. Okay, because they'll simply say you need to have container runtime like container install, but you will not find any instructions. Okay, finally they will install Kubeadm and then start to bootstrap the cluster, but you need to know how to install containerd and all. Of course, you can go to containerd GitHub and then find all the instructions related to installing containerd. Okay, they already have it here. Okay, you can see here, when you are installing containerd, they'll also show you what all things you have to install. Okay. After containerd, you should also install renc. So from here only I took the references. After renc is installed, if you scroll to the bottom, they'll also ask you to install CRA. Okay. So every tool has its own Git repository. CRA has its own Git repository. RUNC has its own repository. I can simply say RUNC GitHub to find all the releases of RUNC. Okay. And this is, I mean, if you go to the releases page, you will find the releases for all the architectures. Okay. RUNC for AMD 64. Okay. So if you just right click and click on copy link address, okay, so you'll get the download link. So the same link I've already used it here. Okay. So this would be the link version 1.1.12. Okay. You can see this is version 1.1.12. I updated it recently. Okay. Any questions, guys?
So is this CRI is a new development or a new update in the Docker?
Yes, CRI, it's an interface, right?
Correct.
Yeah. So if you go to containerd also requires CRI. It is
Any
given.
container runtime requires a CRI to talk to Kubeadm. Is that correct?
No, no, no. See, kubelet will use a CRI. Okay. So if
Right.
you see here, by default, Kubernetes uses container runtime interface CRI to interface with your runtime.
Right.
Okay.
I mean, is it a new development or a new update to the Docker?
No, it is there already.
Okay. So where is the change is coming up now? Because you are saying that installation is now a bit complex now.
Yeah. So previously, if you look at the GitHub repository, this repository, and if you look at my very old uh, setup, okay, probably I think I removed the old setup. If you see, I used to use Docker. Okay. After Docker, if you see these set of instructions, they are very minimal. Okay. I used to install Docker and then simply install Kubeadm.
Okay.
Okay. But now if you look at the latest 1.28 or 1.29, I'm installing containerd, RUNC, CNI, all these components separately.
Right.
Okay. And by the way, what is the CRI/CTL is? It is just like what do you say, a Docker CLI. Okay. So CRI/CTL can talk to any container runtimes. Like just like you do Docker PS or Docker image ls, you can simply do CRI/CTL image ls, CRI/CTL PS. Okay. So CRI/CTL is a common CLI tool. So that is compatible with all the container runtimes like containerd and all. Okay. So ideally contain CRI/CTL is not required. Okay. The reason why I'm using CRI/CTL, I'm installing it is in case if you want to find images or containers and all, you can simply use CRI/CTL. In fact,
Other
CRI/CTL can
images.
also be used, yeah, in place of kubectl also. It also supports kubectl commands like listing all the pods. Okay, like that. Okay, so earlier we were using Docker images, right? But Docker CLI is for Docker container runtime. Okay, but for container runtimes like containerd, okay, you can use CRI/CTL. Okay.
So this becomes a container runtime agnostic.
Yeah, correct. Okay, so if you look at the CRI/CTL documentation or else here, okay, again it uses the socket file. Okay, yeah, this here, which means the CRI/CTL is not limited to any container runtime like containerd and all. Okay, it ideally talks to the socket. Okay, in fact, you can also point CRI/CTL to talk to the Docker socket. Okay, so the same has been mentioned here. Okay, so what I did is after installing the CRI-CTL, okay, I gave it some configuration like use this socket so that CRI-CTL can talk to containerd. Okay, if I replace that with other container runtimes, like instead of containerd, if I'm using cryo, okay, I can still use CRI-CTL to talk to this cryo, provided I update this configuration, okay, to point to cryosock. Okay. Any questions, guys?
Understood. Yeah. So
Others?
at the end of the day, there will be multiple sockets. We can use those sockets to talk to the container, or there are specific type of sockets.
No, if you have multiple container runtimes, you will have multiple sockets.
Obviously. Yeah. So I mean, this socket is by default, right? Since 1.0 or 1.12 in the Docker, it is not no new, right?
Sorry, it is not.
New one, container.
It's not new one.
We
Okay.
can't multiple sockets, right? We can use only one, right? I mean, at a time.
At a time, yes, correct. If you have multiple CLI tools, each CLI tool you can configure to talk to a different socket.
Right.
Okay. So for this installation version 1.29, we need to take one master node and I'm going to take one worker node. Okay. Now you can take any number of worker nodes, and for master you need to use T2 medium type in case if you're on AWS, because this has 4 GB RAM and 2 vCPUs. For workers, you don't need to use T2 medium. T2 micro is also sufficient. Okay, because it won't run your master components. Okay, but for this example, what I'll do is for this demo, I'll take both as T2 medium. Okay, but you can take one as T2 medium for master components and T2 micro for your worker nodes. Okay, so I'm going to launch two instances. Okay, so depending upon your requirement, you can create any number of worker nodes. And OS, I'm just taking Ubuntu because all the instructions from the official documentation are for the APT package manager. So I'm just going to take Ubuntu 20.04. Okay. And here instances type, both I'm selecting it as T2 medium, but you can select T2 medium for master and T2 micro. Okay. For your worker nodes. So key pair, I'm going to create a new key pair, or else if you already have an existing one, you can use it. Okay, I'm just going to call this as KH and then create a key pair. Okay, I'm just downloading this. And networking, I'll configure it later. Okay, so 8 GB is sufficient for me. So let me launch the instances. Okay, so once your instances are launched, what you need to do is you need to change the host name. Okay, and also open some ports. Okay, so if you want to know what all ports to be opened, you can just refer this link, ports and protocols, for understanding on what port numbers your components run, like API server listens on 6443. Okay, etcd on these API server, kubelet API, kube scheduler, controller manager. Okay, on all these port numbers. On the worker nodes also you require these ports. So along with this, you need to also open ports for your third-party container networking interfaces, CNI plugins like VNet. Okay, so VNet requires 6783 and 6784. Okay. So I mentioned all the port numbers, so we'll be opening all these. Okay, so for this, what I'll do is uh, since both has the same security group, okay, because I launched them with the same security group, I'll combine both these, but you need to make sure that master node has only these and slave nodes only has this. Okay. So let me find out what is the security group that is common for both. Okay, so this is a security group. So let me edit the security group rules. Okay. So for API server 6443 TCP is required. Okay. IPv4 and 2379 to 2380 for HCD. Okay. So 2379 to 2380. Remember, we are opening a common security group, so which is both for master and worker, but you should use two separate security groups. Okay. And for VNet 6783 and 6784. Okay, 6783 is TCP. Okay. 6784 is UDP. Okay, just select custom UDP and then write 6784. That's the UDP. Okay. And the other one is 10248 to 260 for all the kubelet, kube scheduler, controller manager, and all this. Okay, instead of opening separate ports, okay, I'm opening the range that is from 48 to 60. Okay, you can be very specific depending upon the requirement. And also for all the node port services, you'll understand about what are these node port services later. Okay, so node port services, you know, one second, let me remove the spaces here.
Here,
30,000 to
Vikram, can you share this?
32767. Sorry.
Can you share this GitHub link? Your GitHub link.
Yeah, I'll share. Okay, and I think all these are also open. Okay, so these are all the required, inbound rules. Okay, remember, for VNet 6784 is of UDP. I've also mentioned the port, the protocols. Okay, so if no protocol is specified, assume it is, TCP. Save
So,
these rules.
Vikram, these anywhere has to be given, or because for database we have given anywhere.
Where?
I mean for security groups, access
Uh,
from anywhere. So is that fine, or we should be
it is
specific?
fine for now, but uh, offer all the worker nodes basically receive the traffic only from the master node, right?
Okay, yeah.
You can restrict that IP address.
Okay. For HCD database, so it should be anywhere, or we can restrict that as well.
HCD, so basically you can do one thing. So if you're installing your entire cluster in a VPC, you can make sure that you can restrict it to that VPC only.
Okay. Yeah,
But
thank you.
Cube API server should receive the traffic from anywhere.
Yeah.
Okay, because that is an entry point to the cluster.
Mm.
Okay, all the other components they communicate internally. Okay, but API server should receive the traffic from from outside as well, from any IP address.
Okay.
Or else, let's say if you have any bastion host or any host from where you want to access API server, then make sure that API server receives only traffic from that bastion host. You can also secure the API server like that. Okay.
Yeah,
So I'm
got it.
just naming this as master just for my identification, and then I'll just call it as a slave 01. Okay, and then I need to SSH into all of this. Okay, so I'm using MobaXterm. Let me create a new folder. Okay, it's right click, new session, SSH session. This is the IP address in the bookmark. Okay, uh, I took the wrong IP address. Just a second. Yeah, sorry. So I have to take the IP address. Okay, in the bookmark settings also, I'll just replace it with, I'll just say it is K8's master just for my identification. And in the advanced SSL settings, use a private key, and then, just give the name. Okay. After that, yeah, in the specify username, since we are using Ubuntu machines, just type Ubuntu. Okay. Okay, so we are logged into master. Similarly, right click on this master session and then click on duplicate. Edit this duplicated one. Go to bookmark settings and first change it to something like slave or worker, whatever it is. And then IP address of this slave. Okay, this one. So now I'm logging in into both these machines. Okay. So I have to change the host names. Okay. So if you look at the host names, so basically they will be different. Okay. So using host name CTL utility and then set hyphen host name. I'm just calling it as master. Okay. So let me do one thing. Let me become root first. And then, set this as master. Similarly, log into slave, become root, and then just call it as slave 01. Okay. The first thing is done. Now, so what we have to do is we have to disable swap on all the machines. Okay. So we need to run the below commands on all the nodes. Okay. So let me just copy these commands. Okay. So instead of executing in two different tabs, so there is this multi-exec mode here. Okay. In mobile external. Okay, if you simply copy something and click on multi-paste, it will paste in both the windows. Okay. Otherwise, you can paste these separately in your sessions. And then once this is done, you need to install Containerd. Okay. Just a second. I think I did not update the link. Okay, so this is the link to download Containerd. Once it is downloaded, okay, you can extract it. And then this is a service file. You need to move it to the system folder. Okay, and then reload the daemon. So I'm just doing all these in a single go. Okay, just click on multi-paste. So it will be pasted in both the sessions. And then I successfully, enabled those services. Okay. So how do I know whether Containerd is installed or not? Again, I need to use the same command, systemctl status Containerd. It is just like you run systemctl status docker. It is now Containerd. Okay. Remember, we don't have any Docker installed. So if I try to type Docker, it will simply throw an error. So we just installed a container runtime. Okay. And then we need to install low-level container runtime and then a CNI plugin. So let me just copy these instructions and then paste it. Okay. So RUNC is also installed and then install CNI. Okay. So what I'm doing is I'm just directly downloading the required, binary and then extracting it and then moving it into a particular directory, which is expected. Okay, so all these are directly from the documentation. Okay, so I'm not doing anything of my own. Okay, and then you need to install CRA-CTL. So why CRA-CTL is required is even though you have Containerd, you don't have any tool, okay, like CRA-CTL and all, to basically talk to Containerd for creating containers, creating images and all. Okay. So what I'm doing is I'm trying to install CRA-CTL for version 1.29. So this is not a Kubernetes version. So this is the version of CRA-CTL. Okay. And then I download it. Okay. So let me just copy these 4 instructions first. Okay. So I think I installed it. Okay. So if I just type CRA-CTL, okay, it is responding. But if I just directly type CRA-CTL PS, it will throw an error, because even though CRSETL is installed, it is not configured to talk to any container runtime. Okay. So I need to create a config file under etc CRSETL YAML. Okay. So this is the configuration for CRSETL. Okay. So I'm configuring CRSETL to talk to containerd. Okay. So let me just take only these instructions and multi-paste it. Okay. So now I created that configuration. Now, if you see, if I do CRSETL PS, it is actually able to talk to containerd. Okay. Now, once this is done, so there are some configuration changes to be done. Okay. So that will enable IP v4 forwarding and all. Okay. So these are also directly taken from Kubernetes documentation, and I have given the link here. Okay. Just paste all this. And finally, so we need to install kubectl, kubelet, and kubeadm. Okay. So for this, you need to install the dependencies like cserts, curl, apt transport, and all this. Okay. So once these are done, you need to add your Kubernetes repository before installing kubeadm and all. Okay. So let me copy these 3 instructions. Okay. So after that, we'll update and then install kubelet, kubectl, and kubeadm. And also we will mark them, we'll set them to hold so that they won't be automatically updated or upgraded themselves. Okay. And then once it is done, you can just do kubeadm version because we have installed kubeadm. Okay. You can see it is 1.29. Okay. Now, we have installed all the required dependencies, both on the master and the worker node. It's time we bootstrap the cluster. Okay. So for bootstrapping the cluster, you can refer again this Kubeadm Kubernetes, and then just see this link, creating a cluster with Kubeadm. Okay. You just have to run a single command called Kubeadm init. Okay. So this is the only command that is required. Okay, so when you do this, what will happen is Kubeadm will try to pull all the images, okay, of API server, scheduler, controller, manager. So there are multiple ways your components can run. Your components can run as a system service. They can in fact run as a container also. Okay, but in case of Kubeadm, okay, all your control plane components themselves run as pods. Okay, clear, guys? Say
Yes,
again,
we
please.
can.
They themselves run as a pod. Your API server runs as a pod, a scheduler runs as a pod, controller manager runs as a pod, HCD runs as a pod.
Okay. Yeah.
Okay. So ideally, you know, when we install Nginx, right, we would do apt install Nginx, right? So what apt will do, it will download Nginx package and it will run as a system service. So using systemctl status Nginx, we can find the status, right? Similarly, Nginx can also be run as a container, correct? Right?
Yes.
Okay,
We haven't installed cluster yet, right? So in
Hmm.
the stage
correct.
only.
Yeah. So actually, if you just look at the APS server Kubernetes, okay, I'll just go to GitHub. Okay. So from here, APS server code can be downloaded. I mean, I can just go to the releases. Um, or else I think, just a second. Kubernetes binaries. And if you go to Kubernetes download, yeah, so these are all the binaries. Okay, kubectl, kubeAPI server. So these are all the bin files. So where I can download and I can simply run them. Okay, like in case of Windows, it is exe file, or in case of Linux, these are simply binary files. Okay, so this is one way where you directly download the binary and run your component. The other way is running itself as a container. Got it?
A container is
Got it.
not on the cluster. Like initially we
It's
started.
in the cluster. Okay. So, it creates a lot of confusion. Like even before creating a cluster, how can the component run as a pod? That's the question everyone gets, right?
Yes.
Okay. So it is possible using a concept in Kubernetes known as static pods. Okay. So for creating the static pods, you don't require to, do any additional changes. Static pod definitions like YAML files can be put in a standard location, and Kubelet will automatically pick those definitions and create those pods. You don't have to manually run kubectl commands for creating such static pods. Okay. It is just like you put the files in one known location and automatically those containers will be created. I mean, pods will be created by Kubelet. Got it? Understood, yes?
Okay.
Okay, I know it creates confusion, but I'll explain them later. Okay, so just like if I do kubectl run, it will create a pod. Okay, or else if I have any YAML file, I need to apply that YAML file to create a pod. Okay, but static pods are not like that. I mean, there is no need to create using kubectl commands. You put the pod manifest file or the definition in a standard location which Kubelet can access, and Kubelet will automatically create that pod for you. No need of any user input. Okay. So when you're bootstrapping a cluster with Kubeadm, what Kubeadm does is it will collect all these manifest files and then put it in a location where Kubelet running on the master node can access it. Then Kubelet on the master node will read these manifests and it will create a pod automatically. Okay.
Okay. Only control plane components, right?
Correct. No, not only control plane, you also have this thing. I'll show you. Okay. Just give me a moment. Yeah. So now Kubeadm init will start bootstrapping your cluster, and your Kubeadm init can also take some arguments. Okay. Let's say your VM has two different IP addresses. Okay, which IP address you wanted to use? Uh, so that API server can only listen on that IP address. Okay. Similarly, if you want to configure a timeout or anything like that. Okay. So there are a lot of configurations available for Kubeadm, but I'm not going to go through all those configurations. It's not required. Okay. So what we will do is we will simply run Kubeadm init on the master node. Okay. So on the master node only, we have to run Kubeadm init, but Kubeadm init internally pulls all these images. Okay. And Kubeadm init has a timeout of, I think, 5 minutes. So within 5 minutes, if it fails to pull all the images, okay, it will time out. And then again, I need to delete all the Kubeadm configurations before doing Kubeadm init. Okay. So that's an extra headache for us. Okay, so now to avoid it, what we will do is we will manually pull all the container images using Kubeadm config images pull command before running Kubeadm init. Okay, in fact, if you run Kubeadm init, this command will be executed, but there are chances of getting a timeout error. That's the reason I'm pulling the images first. Okay, you can see here it is pulling API server, controller manager, scheduler, proxy, core DNS, HCD, all are container images coming directly from the Kubernetes registry. Yeah. And then I need to use Kubeadm init. So what this will do is So this will start your cluster. It will start bootstrapping your cluster, like it will create all the certificates required for the components to talk to each other. Okay. And now this is where, all our components manifest files lie. Okay. So if I just go to this location, etc Kubernetes manifest, you can see these are all the manifest files. Okay. You can say these are all the pod definitions. Okay. So kubelet on this node basically read all the manifest files from this location, and automatically it will create them as static pods. Okay, that's the reason why even before your cluster is available, all your components runs as pods, because these are configured to be static pods. See, there is no difference between a static pod and a normal pod. Both definitions are same. The only thing is static pods are created automatically by kubelet by reading the definitions from a standard location. That's it. Okay, so how do I delete a static pod? Just go to the location where you have the manifest file and delete the file. Okay, and automatically that pod gets deleted.
So can
Clear,
we
guys?
use static pods as a system pods so that
It can be.
yeah, okay.
Okay.
Uh,
A
Even
normal pod can also be static pod.
okay, we can put some YAML in this location. It will
Yeah.
read.
So if I have a specific pod definition and if I put it here, within seconds you will see that pod is created. If you try to delete a pod using kubectl command, you won't be able to delete it. Okay. The only way you can delete is you just delete the YAML file, you pasted it here in the standard location. Okay.
But Vikram,
I,
here in this YAML files or images, right, we couldn't able
mm.
to find the kubelet. So we need to install separately or?
See, kubelet we install, right?
So yeah, so this will not run as a pod. So it is run as a service always.
Correct. Yeah. So I'll
Okay.
show you that also. Okay. So now, we just started the cluster. Okay. But in order to talk to the cluster,
Can you
okay,
increase the
like
font
the
size?
API server. Yeah,
Font
yeah.
size?
1 second. Yeah, 1 second. Okay. In order to talk to the API server, we need kubectl. Okay. Kubectl is the utility. So kubectl is already installed. Okay. But the problem is it is not configured. Okay. So kubectl, if I try to get all the pods, it will fail. The reason why it is failing is it is trying to find the API server um, at port 8080, but this is not where your API server is running. It is running on 6443. Okay. Because kubectl doesn't have access to that configuration file, it is failing. So that configuration file is usually available here, admin.conf. Okay. So ideally what we need to do is we need to just move that file uh, into your home directory under a folder called .cube. Okay, that configuration file should be available with the name called config. Okay, so ideally what you need to do is you need to become non-root and then execute all these commands. Okay, but you can still do it as the admin user. Okay, so if you're doing it as an admin user, this kube config file will be in the root user's home directory. Okay, now what I can do is I can simply say kubectl get pod. Okay, so there are namespaces concept here, but if I try to list all the pods in all the namespaces, okay, so basically, you can see all the pods running. Okay, some are in the pending state. We'll see why. Okay, so once you have the configuration set, you need to actually install a pod networking. Okay, so there are a lot of pod networking add-ons like VNet, Cilium, Flannel. Okay, so there are a lot of them. Okay, some support networking policies, some doesn't support networking policies. Okay, so these are all the pod networking plugins. Okay, so we'll be using VNet. Okay, so that will be somewhere here. Yeah, VNet. Okay. And to the link to install that VNet is here. Okay, I'm just copy pasting it in my master node. So it is only required in the master node. In fact, this container networking, will also run as a pod. Okay. If I get all the pods, okay. So now as soon as your networking is available, you can see the core DNS, which is responsible for your DNS solution, also tries to start. Okay. Now within some time, you will see that all the pods in the running state, your core DNS, HTTP API server, controller, proxy, scheduler. So all runs as your pods. Okay. The other things like kubelet, they all run as service. Okay. If I just say systemctl, status kubelet. Okay. So they all run as a service. Okay. Clear, guys? Okay, so there are certain configuration that kubelet will also read from every worker node. Okay, so one among it is var lib kubelet. Okay, so if I try to check the configuration that kubelet um, will run, var lib kubelet config.yaml. Okay, so in this configuration, you will see the location that kubelet will read for fetching the static pods. You can see here. Okay.
What is that location? Can you scroll up?
etc Kubernetes manifest. So which means any pod definition that you put it in this location, okay, automatically kubelet will read it and it will create a static pod. Okay.
I'm in the kubelet configuration file location. I mean,
Oh, that one. Yeah, this. Okay, you can easily find it if you try to uh, get the status of your kubelet, and you'll find it here. Okay. Clear, guys? Okay. We still have some more steps to be completed. So once you install your pod networking, okay. So currently you have your master node, but what about your worker node? Okay. So let me see how many nodes I have by doing kubectl get nodes. Okay. You can see I only have a master node. This is the name of the node because you have used hostname CTL utility to change it, and we have set it as master. Okay, and this is the control plane because it is running all the control plane components, and the master is also running version 1.29, which is the latest version of Kubernetes. Okay, but where is the worker node? Okay, so we did not join that worker node. Okay, so that worker node requires a join token. Okay, so this is the join token. You need to take this Kubeadm join command, and you need to paste on all the worker nodes. Okay, if you have 10 worker nodes, you need to just paste it on all the worker nodes so that it will join the cluster. Since I just ran that command, um, in the what do you say, in the slave machine, now you can see one more machine is added, which is not a control plane. Got it, guys? Okay, as a test, what I'll do is I'll create an Nginx pod and then I'll expose it through node port service. So you'll understand what is this node port service and all later. Okay, I created a pod and then I exposed it through a node port service. So kubectl get pod. Okay, you can see Nginx pod is in the running state. And if I look at the service for this Nginx, we have used node port as a service name. And then this is the port number. Okay, 30163. Okay, so why this is 30163 is, so all the node port services, okay, will use the port range from 30,000 to 32767. So a random port in this range will be automatically assigned for all the services that are node port. Okay. So in our case, the service name, the service number is which one? 30163. Okay. So how do I access my Nginx application is you can use any IP address in the cluster. Okay. You have a worker node and a master node. You take any IP address, okay, of either the master node or the slave node, okay, and then colon the port on which your Nginx is running. Okay, you can see you're getting the Nginx response. Similarly, I can take the slave machine's IP address and then replace it. It will still give you the same response.
Vikram, you use the join command from the instructions of installation, right?
Yeah, correct.
So down the line, if I add one more instance, how do I get my new join command?
Okay, that's a really nice question. Okay, so Kubeadm join has, I mean, you can create one more join token. Okay. Um, join. So can I,
Okay, there's a CLI to create new.
yeah, I forgot the config join. Yeah, kubectl Kubeadm token. You can create one more join token. Okay, so join tokens can be anything, any number of join tokens. It's not only one. Yeah, Kubeadm token create. Yeah, Kubeadm create token create. I think print join command. This one. Okay,
And
you,
the
you can use
workload
this.
should be running on the worker node, right? So when you try to access master node also, it is giving the access, right? For
Hmm,
the Nginx service. So why is it
correct.
so?
Because service is a cluster-wide component. Service is not restricted to a single node or a node in which your pod is running. It is a cluster-wide resource.
Okay.
Okay, so if I just list on all
Vikram,
the pods,
we installed WaveNet only on the master node. Any specific reason for not installing on the worker node?
yeah, so that is again another good question here. So yeah, VNet, even though, see, I installed VNet as a pod, okay? And since I have kubectl and its configuration only on the master, I can run all kubectl commands only on the master node. Okay, that's the first thing. I can't run that kubectl command on the worker node. So when I can run on the worker node, provided that kubectl config, kubeconfig is pasted in the worker node, uh, then I can run. Okay, but ultimately where exactly your request is going, your request is going to the API server only. Okay.
Right, correct.
Then why this container plugin is installed only on the master when you require that instance on the all the machines is, if you look at this VNet, okay, so let me get all the pods and also in the wide output. Okay, so wide output will give you more information. If you look at this VNet, it is not a single pod, it is they are two. So one is running on the master and the other is running on the slave. Okay, got it?
Okay, so it
If
automatically
I just
creates it.
add one more slave, automatically this VNet instances will be scaled up. Why this
Okay, got
is
it.
this is the behavior is if I just get all the daemon sets, okay. So your VNet is running as a daemon set. So which means automatically there will be one instance of a VNet pod running on all the worker nodes. I mean on all the nodes. Similarly is the case with kubeproxy. Kubeproxy should also be a component running on all the nodes. Okay. Since I cannot install VNet and kubeproxy manually on all the nodes that I'm going to add. So these are running as daemon sets, which automatically creates a pod in all the nodes, in every node that you add.
Got it. That clarifies. Thanks, Vikram.
Okay. So ideally, these we can run as a plain binary files, or else you can run them as pods.
And one more thing. So here, when you see the Nginx pod, right, it
Mm.
is showing as a slave node, right? but still you're trying to access it via a service, right? So that service will be available across the cluster, as in like it can be accessible within all the nodes, is it?
Correct. With all the node IP addresses, you should be able to access that service.
Okay, okay. Okay, so we can use the master IP and then with the port we can use. Okay.
Correct. Yeah. Ideally,
got
node
it.
port service we won't be using. We'll be using a service called load balancer, where you'll get a single IP address. Okay. We won't be using any node IP addresses and all. We'll be ideally using load balancer IP addresses.
Oh, thank you.
Kubernetes also demonstrate.
Sorry?
Kubernetes also demonstrate.
No, CodeDNS is not a daemon set. It's a DNS solution, right? It runs on the master node.
Why there is node as slave one in the first line, which is highlighted just now? I mean, it's on slave 01.
It's Nginx.
Oh, sorry. Thank you.
Okay. See, you can remember like this. So whenever a component needs to update some configurations on a node, that should run on that specific node. Okay, like VNet updates some configurations on the slave nodes and master nodes. Okay, kubeproxy also does the same thing. That's the reason why you have them running as daemon sets. But core DNS, it is a DNS solution in the cluster. It is not restricted to any node. Okay.
Yeah. Vikram, two questions. One is like, why do we install CNI here? I mean, initially we installed CNI also, right? When we are installing container, the D. So, I mean, do we need to install CNI before installing VNet?
Yeah, correct. That's a prerequisite. In container D, they have it.
Okay. And one more, so even before container we are starting using container D, previously using Docker, right? So Docker also, I mean, Docker has this Docker SHM, which also in turn talks with container D only. So container D is existing like from very
Within
beginning.
Docker. Yeah.
Within Docker. Yeah. So so they just removed the one layer like SHM. That's it, right?
Correct. Yeah, so someone is asking static pod will only run on the node where it is configured. Yes. So if you put a YAML file on the master node, so it will run only on the master node. It is a pod.
And the container D, so when we shut down this machine, right? So it has to be restart, right? Like it will automatically restart, or do we need to configure that one as well?
Sorry, can you come again?
So can we, so Docker to run it from when we reboot the machine, right? So at the point of time we want to start the Docker, right? So at the reboot time, in this case, do we need to configure that as well for container D?
I think it is already enabled, right? We already enabled it. In the, if you see here, it is already enabled.
Okay.
Okay, you can see in the instructions I did enable hyphen now here.
Okay. Yeah. So when it comes to a T2 medium, right? So like how much cost it will take for you, like it we use for 1 hour or like 2 hours?
I'm not
Generally.
calculated it. Basically, I don't use this now. I'll immediately delete these instances. Okay, so locally I have Docker desktop, which also provides single node Kubernetes cluster. Okay, so mostly I'll use it. Otherwise, what I'll do is I'll show in the next session. I'll use DigitalOcean Kubernetes cluster. Okay, which costs me very less. Within 3-4 minutes, I'll have the cluster. Okay, and then I'll work with it, and then immediately I'll destroy it. Okay, I can
Mhm.
do that every day, and it won't even cost me, I think, $2-3 a month. It's very cheap actually.
In DigitalOcean, is it?
In DigitalOcean, yes. And that's easier. Actually, you just have to click a few buttons in the UI. You'll have the cluster up and running. They'll give you kubeconfig file. You just have to download your local machine and then talk to the cluster. Once you are done, just destroy it. Next time, if you require it, you just create it immediately within seconds.
Okay, okay.
I'll show you that also tomorrow.
Vikram, one question here. Basically, we used Kubeadm and we built a single node cluster, right? Can we make it multi-node cluster?
It's a multi-node cluster only using Kubeadm.
But we have only one master.
So multiple
node, right?
masters also it's possible using Kubeadm. You can see there is also a link creating highly available clusters with Kubeadm. This is also there.
Okay, okay. So we
It
can
is also
create
possible.
it as a single master node, and then at any time we can add a additional master node into the cluster.
Correct. Yeah.
Okay.
I have one question. In one master, multiple worker node, if a master goes down, is there any downtime for the application?
Downtime for the application. Yes, because you won't be able to access the application, right?
Yeah, but in case of, I mean
See,
to say downtime
only
for, yeah,
downtime. I mean, if you're trying to access the API server, then it won't respond.
right,
But
right.
your worker nodes, pods, and all will be still running, right? Those are
Yeah,
not dependent on the your master components.
right.
Okay.
My application would be on the
Uh,
worker
uh,
node. But,
Correct. So
in
you'll still be able to access it, but the thing is, the master components and all will be down, so you won't be able to uh, query the API server for the latest information and all.
okay, so there won't be any application downtime, right?
Correct. Yeah.
Okay.
Vikram, one question. So, this is got my misconception. Like, I heard like since Docker is no longer being used, I mean the Docker commands, we are moving to containerd. So the images which we use by using Docker build commands will still support. I mean, these are just building images. Docker,
Correct.
right?
Images, see, Docker, you'll use it for all the other activities like image creation, pushing the images and all. So Docker is still there. Only thing is they are not supporting Docker shim. That's the only thing. You will still use Docker.
Yeah, I mean for Docker commands we cannot use, right? I mean that's
Correct. Within the cluster, you don't have access to the Docker daemon, but you have access to the container daemon.
okay. So the commands which we use Docker PS or any other commands like Docker copy or
They
something.
won't work. You should use CRACTL. That's the reason why I installed CRACTL. Okay, so if I just use CRACTL and then PS, you'll find all the containers.